essentially the big role of my piece is to take kind of these theoretical concepts and these physiological concepts and move them into what do we actually know and what have we actually observed about resistance training, concurrent training, which is when you do resistance training and aerobic training simultaneously, usually during someone's actual athletic season is what tends to be studied, and aerobic training exclusively, and what those impacts are on endurance performance, and in general, what those ramifications are for us. Instead of having to look into the research and dissect, the basics of genetic expression and all that, I'm essentially trying to answer the questions that I wanted answered. Questions like, if I have a marathoner who comes up to me and says, well, can I use starting strength as an accessory exercise for my marathon running? What do I tell them? What is effective and what is going to be the effect of the starting strength program? If I have a lifter who's like, all right, I've gotten through the novice progression, now I want to be a triathlete. How do I modify? What do I modify? And just arguing with people on the internet, because that's just so much fun. So first off, we're going to talk about the determinants of endurance performance. So before we can really get into the literature, we have to look at what people are talking about in the literature. Because when it comes to endurance performance and sport performance, it's kind of a weird issue, because you can always measure, and it's actually relatively easy to measure, performance in the sport. How quickly did they run a mile? Did they run 5K? Did they run whatever distance? It's relatively easy to track. So when it comes time to developing training protocols, however, everyone wants to see, so what metrics am I interested in? What physiological changes are happening? Because otherwise you're just, well, I did X program and my mile got faster. Okay, then how did that work? So that we can fine tune it. So everyone wants to know what determines, what's the limiting factor to endurance performance. And the one that always comes up, of course, is Vo2 Max. Vo2 Max was mentioned earlier. It is essentially the total oxygen utilization in the body, the maximum possible oxygen utilization in the body. Patrizio was talking about it in terms of essentially a plateau, where if you continue to do higher levels of work and you're not utilizing more oxygen to get that work done, that energy has to come from somewhere else other than oxygen. So there is an assumption, because we use as much oxygen as we can to get that work done because it's more efficient, that is our maximal utilization of oxygen. Okay. When it comes to Vo2 Max, there's a couple of things we need to know. One, how it's measured. So normally you would get on a treadmill, you would have a mask on, which is measuring your inspiration and expiration. You would have a heart rate monitor on, which is measuring your cardiac output essentially, but it's measuring your heart rate, and combining those two information with a known work rate, because I have you on a treadmill or I have you on a bike, I know what your work rate is to calculate your VO2 at any given work level. And then as your work goes up, I increase the inclination on the treadmill, or I speed you up. As the work gets harder, I measure how much more you're breathing, and specifically how much less oxygen is in your out-breath as in your in-breath. Pretty simple, right? Kind of also hard to do in a lot of places. I mean, how many people are going to bring this entire, if you've ever had a Vo2 Max test done, A, it sucks. It's just a terrible, miserable experience. And B, it's not very portable. It's kind of expensive, and in a lot of these studies, they try to do secondary measures. What are some of those secondary measures? You see, like the Cooper test, a 12-minute run test, which is literally, essentially, just run 12 minutes and record your time. Takes your body weight and puts it into a calculation. You get an estimated Vo2 Max. You have your YMCA 3-minute step test. Essentially, a lot of these secondary measures, and they've been correlated to some degree in the literature, assume the importance of VO2 in your specific aerobic performance in that race trial, and then therefore back calculate your VO2. This is by no means a systematic graph or representation of this fact, but I took 7 studies that I thought were particularly interesting and demonstrated this information pretty well to kind of point out why that's not necessarily so much. First off, Vo2 Max isn't necessarily maximal, especially the way the test is done. Oftentimes, you will see in numerous studies, sometimes they'll report, and of the 14 runners that we had, 7 did not demonstrate a plateau during this test. And that's kind of like, but the maximum number that we saw, the asymptotic expression, okay, that's the highest VO2 that we saw. We're going to call that Vo2 max. Kind of a problem. This has actually been noted a lot in Noak's work. He covers this a lot in his criticisms of VO2. And it makes us question, is VO2 going to be the limiting factor in sport performance, as people often assume? Second, it is specific to the activity and the measurement. So your VO2 max on a rower, vice on a bike, vice on running, is different. Again, in terms of a universal applicability or looking for a single metric of sporting performance, especially for, say, triathletes, becomes difficult. Trainability. VO2 max actually is highly trainable, which is good. It's good in that purposes, for research purposes. Also, just in general, it's a good thing to know that I can improve that. Not necessarily, however, as trainable as strength. When you look at strength, there is an open variable in strength that I can change to quite a big degree: body mass. I can add more mass, I can add more size. But as all of our previous presenters talked about, there is a level of compromise and exchange within the cell when it comes to prioritizing aerobic and resistance adaptations. So whereas I can put on 60 pounds of muscle mass and double or triple my performance on the squat compared to when I start, if you start off at a 40, at a VO2 max of 40, and you're not really going to see greater than about 75, 80, and your top level, it goes to express somewhat the limitations in trying to improve that forever. And we're going to see that here in 1 second. Finally, there's kind of a complicated correlation of performance. So what I have here is about 7 different studies which have been massed and mixed just to show kind of a representation of what I've seen in the literature when it comes to VO2 max. So first off, these are all in the negative category. So that means that time goes down. These are correlations. So on this side of things, that means your time goes down as VO2 max goes up. On your x-axis, you have the distances that were being checked by the researchers. So here, you have a 10 kilometer run and the correlation between a runner's performance and their VO2 max. Makes sense. Now, we notice a couple of things. One, the shorter the distance, generally there is a looser correlation between VO2 max and performance. Almost like when you see 0.5 or 0.3 correlation, not necessarily so great as a predictor for performance. 2, when you start getting up into the higher reaches in terms of distance-wise, not only do we not tend to see a lot of change in VO2 max's correlation of performance, but it even starts to go down a little bit. So if it starts off at, let's say, a negative 0.8 down here, and I'm selecting this one in particular because that blue and gray combination you see here, 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 and then just the gray here, actually came from 4 different data sets from the same study because they picked the same runners, some of whom went all the way into the 90-kilometer distance right here, but they were all doing distances from 5 going on all the way up to, or going on up to their competitive distance. So we get to see in the same runners how VO2 max correlates the longer they go. One thing we see is that after 10K, their correlation no longer pretty much changes. And the authors of that study imply, and they suggest, a possible physiological limit, essentially that once you get up to about 10K, once you get up to that length of time, about 30 minutes, the physiological changes the physiological limitations, the determinants are pretty much fixed. So the needs of a 10K athlete are the same as the needs of a 90K athlete, with a few differences. Those differences being fatigability and, well, I'd call them psychological, but I mean, really, you have to be willing to sustain running for 90 kilometers in the same direction. Good luck to you. One thing I'd like to point out that's kind of a big deal, and we're going to point on the next slide. So if this is negative, so if this means a higher VO2 max correlates with a better performance, how the heck do we end up with these up here? How could a higher VO2 max, a greater ability to extract oxygen from your blood to the muscles in use, correlate to lower performance? And this is one of those funky things that just comes into play when we read the research. This study in particular covers 3 and 5 kilometer steeplechasers in the Olympics in the 1980s. And when you get to the highest levels of performance, we have to remember that correlation, all it tells us is the correlation from increase. So if everyone has about a 75 VO2 max, because after all, they're all high-level athletes, all of a sudden, other differentiating factors make the difference between performance and not. For instance, I'm just going to run through a couple that I didn't have time to put up there. At 3 kilometers, it was found that a velocity at lactate threshold, we'll talk about lactate threshold, was far more predictive. In 1981, LaFontaine found a correlation at different race distances between 0.08, so virtually no correlation. It might as well not be predictive at all, to 0.91, which is a very tight correlation. Increases in VO2 max, improved performance almost 1-for-1 throughout the literature. A wide spread, depending on people's experience levels and a bunch of other factors. Kenny and Hodgson found that in the steeplechase, the only two things that accounted for 98% of difference between athletes, the anaerobic threshold, so your anaerobic capacity, that's interesting, and body weight accounted for 98% of the difference in the 3-kilometer and 5-kilometer steeplechase. And then Noakes et al., who ran this study, running out all the way on time, found that peak treadmill running velocity, so how fast you can go, period, and velocity at lactate threshold, so when I get enough work capacity, or when I increase my speed enough that I start tipping over into lactate threshold, start going anaerobic, that those two were the most highly predictive. In short, there's a stronger correlation between heterogeneous groups. So if I'm looking at a whole population, this room's worth of people, and we have a whole spectrum between, Olympic marathon runners and new just off the couch, there will usually be a huge correlation between VO2 max and performance. But if I'm looking at people who are relatively the same, either elite or at least experienced runners, we start having to look at more than just VO2 kinetics to explain performance. Moderate to strong correlations when various metrics are compared, VO2 max consistently outperformed. It's consistently outperformed, usually by lactate threshold, by the velocity, which is kind of interesting, by the velocity at some of these different metrics that we'll talk about, and, no surprise here, race time. So if your race time is the marathon, your 10-kilometer race time is actually highly predictive of your marathon performance compared to your peers. This shouldn't necessarily surprise anybody, but it also tells us, again, if we can find incredibly high correlations between 10-kilometer performance and marathon performance, a lot of the time when we think, oh, the marathon is something special, it's something unique in the space because it runs so long. But if the energy system utilization is the same, then the 5K runner, the 10K runner, their needs don't change too much. And then finally, multiple studies demonstrate increases in VO2 max with no performance improvement and vice versa. So there are studies which go for and target increases in running economy that we'll talk about, see other things improve, but not VO2 max, and yet race times will still go down. Other determinants of endurance performance, the ventilatory threshold. So there gets to be a point everyone has experienced this both in the gym doing lifting as well as on running, if you subject yourself to that kind of torture, that eventually you'll do more work and it doesn't seem like you're getting the bang for your buck in terms of how much you're breathing. And that actually it does correlate to a real phenomena. It's the work rate at which ventilation increases disproportionately to VO2. I'm breathing more, but I'm not pulling more air out. And I'm just desperately trying to keep up, but it's not giving me the gas I need. Also called the ventilatory turn point. You'll see this in the literature, and in some sources correlates with lactate threshold. Lactate threshold is one of those metrics that seems to correlate at least more consistently higher than VO2 max, and it has an anaerobic component to it. So there was some discussion of lactate earlier. It is the work rate or oxygen uptake beyond which lactate increases rapidly. So normally, just like you would expect with oxygen, you have an increase in work rate, so you run faster, you do more, and then but with each little increase in work, you end up with a slightly increased amount of lactate, it goes up very slightly, and then all of a sudden there will be a tipping point at a certain work output rate where that will spike up. There are different metrics that we use to measure that, and there are different metrics that we use to measure that we think matter. For instance, if you ever see obla, the onset of blood lactate accumulation, there is a fixed metric of 4 millimoles per liter, I think, of lactate in plasma or blood, depending on where you're measuring it from. And that is used as a fixed metric. Like, we know what their work capacity is when they hit that metric, because it's exactly 4. Because one of the problems in the literature is if I'm just looking at a chart and I see work output increases and it goes up, when exactly was the lactate threshold? It's a curve. Normally in the literature, they'll have, like I say here, they'll have a couple of scientists blinded to the research who will look at the graph and go, that's where it was. And they're blinded to each other's conclusions as well. And there will be some kind of standard by which they agree, yep, that's where it was. That's where it tipped. And there are also certain attempts at normalizing this metric using essentially breaking down a calculation, which is the lactate threshold D. Anytime you read the research, anytime you look into it, you have to be careful about which one they're using. And if you're trying, especially if you're trying to compare the research, you definitely need to know which one they're using, because LTD is almost never, or it's not going to be what a casual observer is going to look at and say, yep, that was the point. Older studies suffer from errors of measurement. This is something we see often. So anytime we look at anything kind of before 1990, sometimes even more before 2000, we have to be very careful looking at the information, because if they didn't check, like whether they were drawing from blood or plasma, that's going to have a huge draw on the data itself, which we don't see that in modern studies, which is good. Makes it a lot easier to compare, but it's something that's important as we're looking through the research. And then finally, the correlation of performance. It does appear to be higher than Vo2 Max, and it's kind of important that it is, in the sense that it is an anaerobic component. It is the point at which I do enough work, or I do work, and now I'm going more into my anaerobic energy systems, because lactate as a process tends to develop and increase as that oxidative system, as the mitochondrial systems cease to be able to provide all of the energy demand necessary to meet the exercise activity. VMART. So there's new metrics that, or not new, but within the last 10, 15 years, where people are trying to figure out the anaerobic component of running. There's a lot of research being done on this, actually, because lactate threshold is acknowledged as partially anaerobic in its usefulness, and it has anaerobic connections to your anaerobic capacity. So how do we measure your anaerobic ability? The first is obviously just to have you run as fast as you can. How powerfully can you run? How powerfully can you cycle? How powerfully can you row? And measure that. So VMART comes up in the studies a lot in Velocity, a maximal anaerobic running test. Very similar to a Tabata concept. You'll have 20 sprints with incomplete rest, not 10 seconds, because that just sucks. But you'll have 20-second sprints, and you will collect the athlete's speed. Usually they'll also try to get some kind of measurement of lactate or VO2 or something like that while they're taking these tests as well. But because they are maximal sprints, you get a better position on their anaerobic capacity. Something that always interested me, I think there's a video of Chad Wesley Smith out there doing a 500-meter row. I can't remember the exact time. I think it was 1 minute and 14.4 seconds. It is stupid. And there are some just stupid fast, and there are some people I know who are like, but how is that? He's such a big guy. His cardio must be through the floor, and he's just so big, and he's a power lifter. Well, what do you think? That anaerobic capacity, that glycolytic energy system that we were talking about earlier, he's got that on lock. He's got the strength, he's got the power that movement, which is in many ways similar to the rowing stroke, at least muscularly, he's pulling with incredible power for each stroke. There is a huge anaerobic component to activities that we often think of as aerobic. And we have to factor that in depending on our measure of the sport. I mentioned the 10K convergence before, and the only reason I mention it again here is because VMART has found to be, and similar, just like the peak treadmill running velocity, just how fast can you run on a fixed metric, have been found to be important to runners even at very long distances, especially the 10K mark. We then have to ask ourselves the question, if a 90K run has anaerobic components to it, then is there anybody who doesn't need anaerobic capacity and strength? Movement economy, I think, is the last determinant I'm going to talk about, or the last big one. Movement economy is your VO2 at a set submaximal pace. So think of the shape of the car versus the size of the engine. So if your Vo2 Max is how much oxygen you can utilize, a running economy is different. It's how little energy you can use to run 12 miles an hour, 16 miles an hour. They'll pick running economy at a specific speed and measure your VO2, how much oxygen you're utilizing in your system before you breathe it out. It's a measure of efficiency by definition. It's a measure of a given output, the output being forward motion or distance covered on the rower or whatever by the amount of a given input, that input being oxygen as a proxy for energy used. Factors affecting movement economy, and it's kind of interesting on this one, so obviously body shape and size. If you're heavier, if you're having to lug around 300 pounds through a marathon, you're not going to be very movement efficient. To get at the same speed as somebody else who's running, a 2-hour, 40-minute marathon, you're doing a lot of work, which should be relatively simple, but it also applies to some sports that we don't necessarily think about. Swimming, for instance. What's your cross-sectional area resisting the water in front of you? All these things will affect your movement economy, and that principle of movement economy applies to every sport, every aerobic sport that we can measure. Technique. Swimming is, again, a perfect example here. You could have all the determinants of performance, but if all you can do is doggy paddle, you'll never be a good swimmer. And that same thing applies to, again, virtually any aerobic sport we do. Neuromuscular qualities. This is something that's going to come up again in the future. So your fiber type distributions and the speed at which you can react. So your fiber type distribution, your 2x is more fatigable, is because it fatigues, but because it goes into an anaerobic mode earlier, you have more lactate at a lower point, kind of how we get into that lactate threshold thing. We also get, people have suggested, for instance, ground contact time, that if you improve in your neuromuscular capacity, even by a little bit, then your ground reaction time for each step in a running stroke or in a running cycle, each movement becomes shorter. And that can, in a single step, it seems like such an insignificant thing, but over the course of a marathon, where you're doing thousands upon thousands upon thousands of steps, it over time reflects in big ways. And then the elastic qualities of connective tissue. So we know that the Achilles tendon and other structures absorb a lot of the energy that we put in the ground and rebound back out to us as part of running. Running would be incredibly efficient if they didn't do so. There are a lot of structures that we have in our bodies that seem almost to fit just that purpose, to enable us to run, to enable us to do this efficiently. Those tissues change and to some degree based on the stimulus that we put them through. It is possible, and it has been proposed by some of the authors here, that some of the benefits of heavyweight training in terms of running economy connect here. And we'll talk about that more later. One thing that kind of surprised me is that it's not really in and of itself a great indicator of endurance performance. In elite athletes more so than others, because again, as I was talking about, Vo2 Max becomes less important. The actual VO2 kinetics become less important. They've already pretty much maxed those out. So now we got to look for other reasons. But at our level, it's a lot less important and a lot less predictive of performance than I would have imagined. General observations, so moving off of determinants now, there's no clear best determinant of performance besides performance itself, which kind of makes the literature, you end up having to measure a lot of different things. There is that 10K physiological baseline. The one I want to highlight, there is not a one-to-one correlation between race performance and testing. On the right, you see Matthew Centrowitz. I don't know if anyone followed the 1,500-meter race in the 2016 Olympics. He managed to win it with literally the slowest time since 1932. He ran it in 3 minutes and 50 seconds, which sounds really, really good to us, since that's almost a mile run. But that, like I said, it's actually the slowest time since 1932. And when it equates to a mile, that's 4 minutes and 4 seconds, which you have high school athletes running that nowadays. In fact, Matthew Centrowitz himself had run 20 seconds faster for the trials leading up to the Olympics. So how is it that he took first, despite what they call a sluggish pace? He opens up. Everyone knows he's got a kick. Everyone knows he kicks it at the end. Nobody quite wants to pass him. A few of the other high-level contenders try to make sprints early or busts early in the race and don't quite claim first place. They don't make it, so they're kind of stuck. Next thing you know, he makes it to he's still holding first. He holds on for 400 meters. All he's got to do is book it. He books it in 50 seconds. and nobody can quite catch them in the finish. Everyone holds their strength too long. So now we're going to get into the studies. Barnes et al., Strategies to Improve Running Economy, Proposed Mechanisms. These are some of the proposed mechanisms I was talking about. The muscle fiber type conversion. One thing that people don't necessarily look at is the fact that 2-bravo converts to 2-alpha, so those highly fatigable fibers convert to less fatigable fibers, even in resistance training. So we kind of assume that we're going to go up the scale towards more explosive by doing explosive training. Even Olympic lifting actually moves things down the scale more towards those 2-bravo less fatigable fibers, which is interesting. Mechanical improvements reducing improving biomechanical efficiency. The idea that possibly someone is weak, so on the drive step for ground contact time, you might give in your hip position, you might give in your ankle position more than you need to, and each step losing some of that efficiency. Hypertrophy of type 1 fibers, reducing percentage of maximal effort for each stroke. I don't know if this sounds familiar to anybody. In the seminars, we get this whole pedal model, that each pedal represents, if you double your strength, it represents half, the new step represents half of your maximal strength. And people tend to go, oh, that's super simplistic. That's way too simplistic for this. And I would agree that it is only one of a number of possible explanations, but when you see it actually presented in the literature, the number of possible explanations for how that works are essentially endless. But that your type 1 fibers, as they grow, even though they don't grow as much as type 2, they are still hypertrophying, they're still getting stronger. One thing that he found, heavy weight training was more effective than strength endurance training in improving running economy. Strength endurance training being your 20, your 25 rep circuits, things like that. Explosive plyometric training also improved running economy. And this is a quote, but of the 6 studies that included a resistance training and plyometric resistance training group, 4 demonstrated greater improvements in running economy following traditional resistance training. This is kind of odd. Paavolainen, in an earlier study, suggested that perhaps explosive training would be better for running economy because it more mimics the run stroke and the explosive return, but that doesn't tend to be what we see in the literature unless. We have Denadai et al. 2017, explosive training and heavy weight training, that's what those stand for, are effective for improving running economy. In this review, instead of comparing the studies that did explosive and heavyweight training, he simply looked at the percentage of improvement across all these different studies and found that they were effectively similar. They found that longer training appeared to have greater effects, kind of a no-brainer on that one. One thing to point out, though, total of 178 experimental subjects. So this is 16 studies that he measures with 20 effect sizes. 178 experimental subjects, so that's averaging a little over 10 subjects per study. When we start looking at statistical relevance and sample sizes, we start running into issues, and you realize that the entirety of the literature, because this is 2017, so in a systematic review, the entirety of the literature includes 178 people with different levels of experience, all different levels of experience when you look at the literature, men and women, different age groups, different training regimens. 2 of the studies involve strictly isometric training. So how much exactly we can pull out of this in relevance for starting strength coaches is always going to be a bit of a tack. Research training and resistance training and aerobic kinetics, not going to go into this or into the studies too deeply because there's just too many. But RT alone, resistance training alone, does not appear to improve Vo2 Max by any meaningful degree. Tanaka and Swenson, 1998, found approximately 3% in some studies. And this is something that we've seen in the previous research before. It's actually, you're not really going to improve your Vo2 kinetics. It does not appear to degrade your Vo2 kinetics either. The risk that you're going to get muscle bound and you're going to get slow doesn't seem to happen. Vo2 Max appears to be less affected by strength interference than than strength is affected by aerobic training. So in both of these reviews, you saw that the aerobic athletes who started strength training saw no decrement in their improvement in their aerobic skill. However, if you started with strength training, you were going to go downhill. And then incorporated aerobic training, it started impacting your strength training. And then some reviews note a small but positive effect on lactate threshold. So concurrent training is where I'm going to kind of go into, and we're going to shotgun some of these studies pretty quick. It's when you do resistance training and aerobic training at the same time. Again, a lot of issues in the literature here, small sample sizes. When you're only dealing with 8 people in your study, I don't care if it's technically, statistically significant because you don't have control over all the variables. You don't know if one person decided, I don't care, I just want the extra credit. They're gonna, slow ball it while they're way in the gym, and now there's one data point out of 8 throws off the rest of your data. Accurate data, but the premises, conclusions, and methodologies make translation difficult. When you have run bros studying run bros, doing strength, you end up with problems, and we'll see that later here in a minute. We don't see many strength bros reviewing this literature and conducting this literature on aerobic training. And again, we're going to see that here. Finally, pressure to find results. There is one study I found is from Iran that I looked into on spirometric parameters, on different lung parameters. And I thought, oh, this might be interesting. Is this important? Because they found that aerobic training and HIIT improved these parameters, but resistance training did not. I looked at the abstract, that's what it said. But I go into the study itself, and the study itself actually says that there was no in-between group differences. There were no significant changes in spirometric parameters in our study that could be attributed to the implemented programs. Why did the abstract say that our findings show that interval training and aerobic exercises significantly improve spirometrics of non-athletes while weight training had no effect? How could you say that something worked and something didn't work in the same study? Well, when you have pressure to demonstrate an effect, then in your abstract you might be tempted to say one thing when your data says, in fact, there were only statistically significant changes in 2 of 7 variables in one of our groups, and there were no between group differences. It's a bit of a problem. So we have to actually look into the studies. So Hicks in 1980, this one anchored the research on the concurrent effect. Sully already talked about it in his 2014 XI presentation. I encourage you to look on it on the Starting Strength site. Great work. He discovered the interference effect, but it was kind of a poorly run study. You work out, people 11 times a week. In aerobic training and resistance training, you work them hard, and sure enough, after 8 weeks, they start seeing gains, and then they see a reversal of gains after 8 weeks. No surprise, you just overtrain them. You just beat the crap out of them. One thing that's not mentioned often is that the SE, so the strength and endurance concurrent group, and the endurance group experienced similar improvements in Vo2 Max after 10 weeks, which I thought was A, fascinating, and B, they didn't even test the strength group because they just kind of assumed that there wouldn't be improvement in Vo2 Max. It's a poorly conducted study, but it draws our attention to the possibility of concurrent training and compromising adaptations, and because it anchors the research, then a lot of things afterwards come to be a problem. And we're going to see this right here at Hakkinen et al. So 2003, they come to the conclusion that if you keep the frequency and volume down, they look at Hickson's previous work and go, well, what if we don't overtrain the crap out of them? So they do 2 days a week for the strength bros, and then 2 plus 2 days. So they have them do the same strength program and have an additional 2 days of aerobic work for the combined bros. Longer study, sample size, it's comparative, so there's no control group, but whatever. They're comparing it to Hickson. The strength and strength endurance group saw similar gains in strength. Strength had much higher power metrics. That's interesting. Strength endurance also showed a 15 to 20% improvement in Vo2 Max. Their conclusions were that 2 days a week is an effective stimulus for both endurance and strength training. Strength gains on this program, they suggest that if we keep the volume down, if we just don't overtrain them, you don't have an interference effect, just because there wasn't the dramatic drop that you saw in Hickson. But I thought it's perfect what we got from Dr. Patrizio yesterday when he showed some of the other literature showing resistance training solo programs by percentage of improvement. 45%, 50% for some groups. And then in our own work, the higher numbers, the 85%, somewhere around there. So after 21 weeks, they saw about 22% improvement. Do we really have demonstration that there was no interference effect? Or just that their gains, because they weren't pushing the limits of their gains, they weren't actually driving strength gains as fast as they could go, we don't know whether the aerobic training slowed down their effect or not. Essentially, was it no interference or was it just ineffective strength? One thing that it does highlight, though, that I want to point out is that it did not compromise the endurance performance. Something I mentioned before, and it's going to come up after. Wilson et al. 2013, it's a meta-analysis of interference. This one is kind of the big honky when it comes into interference. It's actually quite well done as a review. It's almost stereotypical in what you would expect. The strength group saw greater lower body hypertrophy, lower body strength, lower body power. Vo2 Max actually saw a negative correlation or a negative response to resistance training, but it's not statistically significant. So basically, we didn't see anything. No change to Vo2 Max for all intents and purposes. And concurrent training was more effective at reducing body fat between the different studies. He actually, in their review, because they did see some dose-dependent relationships, he comes to a conclusion that I actually think is a pretty good rule of thumb, and we'll see it later in Patroclus' study. But athletes should avoid extended endurance exercise greater than 30 minutes, greater than 3 days a week. Because when he started seeing numbers above that was when he started seeing the greatest levels of interference. Thought that was actually a useful metric, and it's something we're going to see later. One disclaimer I have on this, though. Garbage in, garbage out. Just like we looked at the study on movement economy earlier, and the fact that it only had 178 subjects all across the map, and we know some of the unfortunate state of some of the research available out there. Without going into each individual study, every study that went into this meta-analysis, it can be hard to say whether or not the conclusions can be verified. Tanaka and Swenson, 1998, discusses the competing physiological adaptations. I won't go into them, but they're similar to Barnes. Again, mentions the whole pedal thing through very similar adaptations. Greater ability to produce force, so you have a greater submaximal force, or a less fatiguing submaximal force production. Shocking. You say it in academies, and people don't think it's oversimplistic. One thing that he does point out, and we have seen this in other work, other studies I've talked about earlier, and it will come up again later. Endurance training suppresses power. So you take a group of generally, gym bros, and put them on an endurance program. Their vertical jump will actually go down according to this review, the counter movement jump, which is kind of a fascinating thing, and it suggests the neuromuscular adaptations that compete between resistance training and endurance training, and how important those may be. And finally, it did not systematically review the effects on elite athletes, so it only had to do with recreational run bros. So that's within its limits, but that also tends to be our target market. Sedano had also, we haven't covered elite athletes. What about them? He takes 18 young run bros with really high Vo2 maxes. I think you had to be 65 even to be considered, or something like that. Control, endurance, strength, and strength training. Broke down their training protocols. There's one big problem I have with this study. Look at the S group. So they're 150 pounds and 1.8 meters tall. They're definitely taller than me. And he records their starting 1RMs on the back squat as 202.5 kilograms. So a 445-pound back squat for a 5-kilometer, like a cross-country college runner. Who here knows a D1 program with cross-country runners squatting 450 pounds? So this is when I was talking about run bros measuring run bros during strength. When they say like we're measuring squat depth to 90 degrees, 90 degrees to the point, 90 degrees of knee flexion. Do you really think they're getting to even 90 degrees of knee flexion, which tends to be the thigh parallel to the ground, with 202.5 kilogram back squats? But what they showed is no change in VO2 kinetics. The strength group showed significant improvement in running economy and superior improvements to their 3-kilometer running trial, which is, again, kind of interesting that the strength group would show better than the endurance strength group. And we'll talk about that later in terms of specificity. I like Joyner and Coyle's comment there at the bottom that anytime you try to measure elite athletes, though, you end up with problems. And I'll have to speed through this. Good. Control. One reason I bring the study up also is because the control study, or the control training, actually is very similar to what you see in a lot of colleges today. This is a sample dry land training program for swimmers, drawn from a friend of mine who had someone go to a D1 school. Very similar, and what I'm going to call kind of silliness, that we have seen in this study to be relatively ineffective for an elite athlete. Burkett also, what about older athletes? This one so meets my biases, I really wish it were true. The combined group saw significant increase in strength compared to the aerobic group, and they both saw statistically equal improvements in their aerobic performance. So, yay, there's no interference effect, and the strength group the combined group was superior to the aerobic group. But when you look at the training program, they both worked for 40 minutes, and the combined group just did a 20-minute run and then 20 minutes of essentially nothing strength training. Study duration was short. The absolute change was small, and the change in trend, so for the instance in aerobic performance, in every metric of aerobic performance, the endurance-only group improved or trended towards improvement more so than the combined group in their aerobic metrics. It just wasn't powered enough to demonstrate the significance of that. So again, you have sex not equally distributed, 82% female, but when you have so few people there, it actually means you only have, I think it was 6 men in the study. You couldn't even draw a subsample of men. So there is probably still an interference effect. It doesn't matter how low you keep the volume. Sorry. Research recommendings on timing, Sporer and Wegner. I actually really like this study. They did high intensity, steady state. It really didn't matter what kind of aerobic training they did. They saw an interference effect to the immediate strength training that they did 4 and 8 hours after, but not 24 hours after. So at least in the short term, if you're going to do it, spacing out your aerobic training and your strength training, there's a lot less impact on your strength training from your aerobic work by spacing it out at least 24 hours. One caveat I'll put to that is that they use cycling for this, because cycling has less eccentric damage, which they prescribe there. Can't necessarily say that this applies to some of the higher impact metrics like running. So Androlochus coracoccus, the effect of exercise modality during additional HIIT. This one is fascinating. Don't have too much time to go into it. They took 16 actual strength bros, powerlifters and strongmen, and had them do either aerobic mode HIIT or what you would consider a strength HIIT. So doing, not really EMOM, but sets of 8 to 15 at 60% of 1 RM until they reach a certain RPE with 1 minute of rest in between. Kind of not quite a Meyer-Rep protocol, but something meant to be more HIIT-like. Although it causes us to question the idea, because they achieve similar gains, causes us to question the idea that squat conditioning is superior to aerobic conditioning for aerobic gains. On the other hand, there was no interference from that low amount of work, just twice a week for that one session, which goes back to that recommendation earlier, no more than 30 minutes, no more than 3 times a week, low interference. Useful for these kind of athletes. Again, always a caveat, because there's only 16 people in this study. Contrary findings, so we have to acknowledge when in the research it doesn't fit our biases. Resistance training does not appear to improve swimming performance. In virtually every study that measured it, it did not. Which is interesting, because there's a moderate to strong correlation between upper body strength and swim performance, but yet improving, even in studies where, okay, we measure the correlation, we improved upper body strength, their time stayed the same. There's a lot of questions as to why this may be. It's more technical, so technique has more of a component to it than just strength. Adaptive time. So is it one of those things where you change the body, now you have to relearn how to use this new, stronger body that you've got? Overreaching in some of the training protocols. Did we work them too hard compared to their swimming work? Hard to say. Confounding study design limits interpretation, both positive and negative. HIIT not superior to aerobic training in terms of interference and strength gain. So there's not really a lot of positive evidence that HIIT is superior to aerobic training when volume is matched. Evidence that maximal strength training is better than explosive strength training, but only marginally. I would love to say that training for strength for a marathon runner is going to improve running economy or overall performance more so than anything else, but there was a statistically significant improvement in heavyweight training in some studies. It's not, the research does not conclusively demonstrate that. And then conclusions, and these I can blow through because we've already gone through the studies. Aerobic training interferes with strength gains. There's no one way, it just does. It can be partially mitigated, and we talked about why. Here's some rules and guidelines to do that, but there is interference. Strength training alone won't improve VO2. Resistance training improves aerobic endurance performance. For one of a million possible reasons discussed, resistance training will make a marathon runner a better marathon runner. But will a marathon runner ever do resistance training to the point where they turn into a powerlifter? No, because aerobic training interferes with strength gains. Lifters looking to drop fat should be doing conditioning work. And that's what the research indicates. Half measures, strength endurance work and light circuit work, are less effective for any goal. So that kind of circuit training, that dry land strength training, any attempt, kind of like functional training, to make the exercise, make resistance training, make your gym time look like a run or be energetically similar to a marathon, doesn't seem to work. This isn't really a violation of specificity. It's applying specificity to the things that make resistance training matter to endurance performance. Things like tissue elasticity, things like neuromuscular adaptations, which are which direct or indirectly support that endurance performance, but are not themselves mimicking a run. We can't make our gym sessions look like runs. Resistance training consistently effective in improving sprint and intermittent performance. This, I wasn't even really looking into the literature. But there's almost even no debate in this in the strength training community. Football, soccer, it doesn't matter. You take any intermittent sport or any sprint sport, and resistance training consistently improves performance.